Hello, am I audible? Hello, 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 hello. I think it's too long. Hello, 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 Samantha, are you there? Samantha, are you there? Samantha, I'll just reduce this. Hello, 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 hello. How is my audio now? How is my audio? Okay, somewhat better. Please ignore the background noise. I need to create a function. Let's say I have this function. It basically returns nothing. Let us confirm it by returning either 0 or 1. So I have declared it as int. So basically it receives some input and it should be having a loop that it can iterate certain number of times depending on the input variable, because see, we have some iterations going up to here. We have 4 times, and here when this number is called, we have 3 permutations. So So at this level we have 4 iterations, and here we have 3 and 2. So at different levels this loop will be iterating at different certain number of times. So within this loop I will be again calling the same function, which is this is also known as recursive. So basically so let me take this example first. When I have n equal to 2, the possible permutations are 0 1 and 1 0. So and if n is 3, possible permutations are around 6, and if it is 4 it will be 24. So let's say if we are in this level, then this will act like a base. So we'll be changing this 0th index number. At first we will just take the exact copy, and then we will be popping out 1, and we will be shifting all these numbers to the right, and we will put back the 1 at the front. So 1023, and again 2 is popped out. These numbers are shifted to the right, and 2 is placed at the front, and again 3012. So maybe let me delete this. Let's name this process as swap. So we will create a function that will pops out certain elements and places it at the front or at the selected index. So within the main function we will be having for loop, which is mandatory. So within that we will be calling swap function, that will swap the numbers and stores it in some array. So after that, we will call this function again with some parameters. So for n equal to 4, this loop will iterate 4 times at the first level. So let me declare a variable level. Uh, Let me choose right for the global variables. Level will be global variable that indicates the level at which level we are presently operating at. So this is level 1, let's say. This is level 2. This is level 3. So depending on the levels, we will be having different number of iterations. So for the first iteration, I mean at the first level, so for level 1, there will be 4 iterations. Let me name this. This is main for loop. Okay, so main for loop will be iterated 4 times, giving us those 4 values. And at level 2, so let's say in the level 1 itself, this has been called, I mean swap is called, and we have generated 0 1 2 3, and then within this it will lead to 3 other permutations as specified here: 0 1 2 3, 0 2 1 3, 0 3 1 2. So whenever this function is called, so it will eventually comes back to this function, right? So now this for loop has to iterate for 3 times. So here for loop is iterating for 4 times, and at the level 2 main for loop is iterating for 3 times, and at level 3, as you can see, these are the 3 permutations. So it has iterated for 3 times, and that in that each iteration there are 2 more iterations. So main for loop will be iterated for 2 times, and this is the end, right? So we're not gonna be shifting to any other levels like 4 or anything. So this is the end. So if I have already created, okay, So if level is, if the level is equal to n minus 1, equal to, so for n equal to 4, it has only 3 levels. So n minus 1. So if it has reached this, let's say if n is 4, if level has reached to 3, then it should return back. So this is the level 3. So after swapping, we should not be again calling this function again. Instead, we should return back, right? So we should remove this recursive function and we should add a logic. Let's say if, so same logic goes here. So let me just cut this up. So if the level is equal to n minus 1, then return 0. Else return function. Yeah, perfect. So function will be called again if the level isn't matched with n minus 1. So this is over. So this is the main for loop type. Let me check my audio once if there are any background noise. I'm muting myself. Yeah, audio is good, but whenever I am talking, there is some noise coming from the fan. Rather than that, it actually works. The settings were working. Maybe I can do even better with some other filtrations. I'll do that later. So maybe we have, so this is a function that will be called once, right? So it will be called once in this logic, and we'll be having the entire, I mean, the upcoming permutations. The order of the strings will be set in a array. According to that, this will be sorted out for each and every iteration, like given over here. So this so we are done with this, but we need some parameters. Mainly, we need a conditional variable for this for loop, so that we can decide how many number of iteration it can have. So maybe it's simple. See, in the first for loop we need 4 iterations. So for that I can give the n value directly, and if I subtract that with level, so initially um, level will be 1, right? Okay, level will be 1. So maybe I can, so maybe I'll pass n plus 1. 4 plus 1 is 5, and the for loop will be less than, this will be stored in the, it's a condition, so condition minus level. So for n equal to 4, condition will be 5. So 5 will not gonna be changing, it's constant. So that constant will be subtracted with level. So for level 1 it will be 4. Loop will be iterating 4 times. For level 2 it will be iterating 3 times, 0, 1, 2. And for level 3 it will be iterating for 2 times, that is 0, 1. So yeah, so level is a global variable. Level is a global variable. Let's initialize it to 1. So after uh, each and every time the function is called, level has to be incremented, right? And there is a catch over here. As we go through, as we go through this particular line, I'll mention this now. So as you can see, this iteration, and then put this, and then put this. After going through that and reaching over here, level 3, we need to make this level to 1 or 0. We will figure that out. So we need to reset the level. So in order to have other iterations as well, like this one, we'll look into this. So far now, this logic works. So iterations are taken care. So what are the parameters that we are gonna be giving to the swap function? So basically what we are trying to do is we are having an array of elements. We will select a particular index value. We will pop that out. We'll pop that out and array becomes like this. Let's name this as X. So these elements will be shifted to the right, and this popped element will be placed in front of the array. So this is the process, right? This is the first element, and the first element is pushed to the right. So this is what swap function does to the array of elements. So we need to give the indexing value. So that's it. I think we need to just give the indexing value, right? So if I give the index value, it will swap the elements, and so for level 1, indexing value will be 0, right? So I need to parse level -1. So first level, it will swap the elements in the 0th index, and for level 2 it will swap first index values, keeping the 0th index fixed, and for level 3 it will swap second index values, keeping 0 and 1 index constant. And yeah, basically this is what we want. For a second I thought I was muted. So this is what we will be passing the parameter. and we need to switch it, right? We need to swap it. The swapped elements will be stored in the array. Let's implement swap function. So swap will be taking the index value. Let's name it as index. So this returns nothing, I guess. Let's declare it as void. So we need a duplicate array. Let's name it as 2. I have already implemented a code on this, as you can see. So this is the same code. So this is an array, and the size depends on the n value, right? So we'll do one thing. We'll pass n value as well, or else, sorry, or else we will just declare a global variable which is size that will be equal to n. I'll write that over here. So in size will be same with 10. So duplicate will be cloc n size of int. So these many number of locations will be created. Since I have the index, I need another global array. Um, so this will be the main array, which consists of all these elements over here. So there are around, for n equal to 4, there are around 24 values, 24 permutations, and each permutation is having 4 values, right? So we have written a code that calculates the number of permutations. Actually, I have named it as combination, so it's okay. So it returns the combo, right? We will use this combo, which is actually, okay, comb is right over here. Okay, the returned value will be stored in the comb. So we have a global variable com that holds the number of possible permutations for given number of n. So let's declare this as possible permutation array ppa. So at the very start, we'll, in the very start, we will create a memory of blocks. Let me create the array, a pointer in PPA. So this PPA will be holding some locations which will be of size combo com multiplied by n, size of int. So I'll use this PPA to store all these values. Yeah, I'll name this as PPA. This is PPA. So every element is stored in this PPA. If n is 4, then combinations will be 24. I mean permutation. So comb into n, 24 multiplied by 4, which will be 96. That can hold all these values. So this is the duplicate array. We need to store some values in PPA according to this main this processed data. So what kind of processing that we need to do is, if the index is pointing to this value, to this place, we need to take this out and what kind of code I have written out here. So I have an array of elements 1, 2, 3, 4, and I have given the index value 1. So it takes out the elements from index 1. So it keeps the 0th index as it is. This swap is called every time, right? Condition is 4, level 3, 1 time. Four minus 3 is 1. So only, wait. 5 minus 3 is 2. So 2 iterations, okay. So firstly, I'll be having 0, 1, 2, 3. So 1, 2, 3 is list as it is. So for every first iteration, um, the element is taken as it is, and later on it is starting the swapping. So maybe I need to make a change. This will be taken up. So I can add some other logic. If this for loop is iterating for the very first time, I mean, yeah, so let's say we have, let's name this as f. So f is initially 0 and it should be less than this expression. So if f is equal to 0, then we have PPA, right? Possible permutation array. So this PPA of, so it changes for every iteration. So initially PPA, this value will be stored in PPA of 0, this in PPA of 6, uh, wait a second. Okay, my bad. PPA of 1, 2, 3, 4, 5, 6, 6 4 24. So this will be stored in 24, and this will be in 24 plus 24 is 48. 24 to 47, so 48. And this will be stored in 52 and 72. This is stored in 72. So for the first for loop, first iteration, sorry, we will be passing the level. So we'll iterate for 3 times and then 2 times, right? So the very first iteration, PPA will be during the level 1, PPA will be assigned to 0, 1, 2, 3, and then again 0, 1, 2, 3, 0, 1, 2, 3. I am a bit confused. So initially, PPA will store this, right? 0, 1, 2, 3. We have 0, 2, 3. And in the second iteration, it will store 0, 2, 3 by swapping those, right? So in swap method, okay, it has to swap those. This will be again swap and this as well. Let me remove this. So let's say at the first iteration we have swapped this. Somehow we have did something and we have stored this in PPA, and later the function is called again since the level is not equal to n minus 1. Currently level is around 1, right? So 1, so it's not equal to n minus 1. So let me make this as, let me increment that. So whenever the function is called, the level gets incremented. So initially it is at 0. So whenever the function is called, it will get incremented. So the function is called and the level gets incremented. It's Now in level 2, and in level 2 we have this, right? So in level 2 it will iterate for 3 times, resulting in these 3 values. Okay, so and again, since level isn't matching with this n minus 1, we will call this again, and now the level is 3. So I think this is the last one. So we'll be calling this swap, and we'll have this, and later on that we will just return this, right? So the thing is, 0 1 2 3 0 1 3 2. Plus 3, so 3 minus 1 2, so it makes the 0 1 fixed, and it changes the other elements. Okay, and when the level is 2, it specifies the faster blocks. That means this routing x is fixed, and we will be having these 3 permutations. And during the level 1, entire array will be swapped. This for loop is, you know, wait. Conditions 5, level is 1, 4 times. We will be having 4 swaps. And when level is 2, we will be having 3 swaps. Okay, let's say we have equal to 0. Then we have it number, so we're having 1 swap. This should create 0 1 2 3, and again the function is called. It will iterate for 3 times. So at the first iteration I will again have 1 2 3, and again the function is called. I should iterate for 2 times. Initially I will be having 0 1 2 3, and at the second time I will be having 0 1 3 2. So 2 iterations are complete. Um, Make this as n, and before returning it to 0, we should make that level to some value. I'll tell that number now. So let me draw a flowchart. So level 1 for loop is called 4 times. I have named it as f, right? So when f is 0, we will have 3 iterations. I mean 0, 1, 2, 3, right? So at f equal to 0, I'll be creating 0, 1, 2, 3. So return function is called again. We have 3 possible iterations. So within this, we have 3 for loops. This is 0, this is 1, this is 2. So in this iteration, I will be creating 0, 1, 2, 3, and in this 0, 1, 0, 1, 2, 3, 0, 2, 1, 3, 0, 3, 1, 2. So within this, I'll be having 2 more iterations, and in this as well, and in this as well. This is f equal to 0, this is 1, this is 0, this is 1, this is 0, and this is 1. And here I will be creating 0, 1, 2, 3, 0, 1, 3, 2, 0, 2, 1, 3, 0, 2, 3, 1, 0, 3, 1, 2, 0, 3, 2, 1. So whenever the loop is started, we'll be having swap that will create 0, 1, 2, 3 over here. So this is at level 1, this is at level 1, and this is at level 2, this is at level 3. So it calls the function, it passes the level as parameter. So basically it is now 1 and it will get incremented as 2. So condition, I think we have to increment this over here before the for loop level plus plus. So level will be 2 and the iterations will be 3 times. And again, this f equal to 0, I'll be having, I'll be creating the 0 and 2 group, and then the function is called again. And now the level is 2, right? So 2 will be incremented to 3, and now I will be having 2 iterations. So at the first iteration itself, the level will be 3, right? So level 3 is equal to 4, which is false. Previously it is true, right? So I have changed this. So this is not true. The function is called again. This is not good. If level 3, 4, and time. So, make it n minus 1. Level is equal now, and before returning it, I need to make the level as for returning, it will return to here, right? Swap is called it goes to the next iteration, and the level is 3. The level is 3, and it uh, kind of I think I think I should call this again. So level will be unchanged. So within this, we'll call this again, right? So this will be at level 4. This as well. This as well. So from this, I'll have another level which will iterate for only one time. No, this doesn't make any sense because this iterates for two times. So where will go? No, wait. Keep this as it is. We will change the swap function. We need to somehow include the f in the parameter list as well. So we are gonna be passing the f as well. So swap will be receiving the f. So again, we'll come again. So at first function is called, level is initially 0 and it is incremented to 1. So we are at level 1 and the condition is 5. 5 minus 1 is 4, so it will iterate for 4 times. I have not mentioned it over here, but as you can see, this is the first iteration, second, third and fourth. And then at the first iteration 0 1 2 3, when I call this swap function, I should be having PPA array with this elements at the start, and it has around 96 elements, right? So at first 4 will be filled up with this 0 1 2 3, and within the same level for the second iteration, around in 24th element will be having 1023, 48th element 2013, and 72 72th element will be 3012. So this swap function should have the functionality of assigning values to the PPA according to the level and the iteration count. So and the level is not equal to n. Actually this is not n, this is n minus 1. So function is called again by passing the level count. Level is 1 and it gets incremented to 2, and now it's gonna be iterating for 3 times in level 2. So if I focus on the first iteration, I'll be having the swap function call, and 0 1 2 3 0 1 2 3 will be assigned to the PPA. Right, okay, and then again level is not equal to 3, it is actually 2. So again it is called, level is incremented to 3. Now it's gonna be iterating for 2 times, which is this, and swap is called again. PPA will be assigned with 0 1 2 3. But now I have this condition true, so it returns 0. It comes back to the this line, and it goes back to the for loop, and it again swaps, but the f value now it is 1, so PPA indexing will be changed accordingly. And then and then and we need some other mm, we need some other counting as well. We need some other variable as well. We will discuss that later. So now it will be assigning 0 and 3 to the PPA, and again it returns back. So it returns back, and the for loop fails because it has to be iterated 2 times only. So this fails down, right? That means it comes out, right? Comes out. So at last when we return 0 over here, so it returns back to the level 2, and now the f will be 1, so it swaps, and according to the level and f value we will assign the values to the PPA. If it's 1 0 2 and 3, so whenever it returns from here, level has to sort of decrease, right? It has to decrease. So level minus minus return 0, so it is at 3, so we have to decrease the level whenever we are going back to the previous level. So yeah, so kernel level is 2, and it has to be less than 3, so now f is 1, start 0 2 1 3, 0 2 1 3, and the level is not equal to 3. Function will be called again. I will increase it to 3, iterate it 2 times. So the first time it will be assigned to 0 2 1 3. Okay, we have to declare a variable that keeps track of PPA index value. Okay, so let's name it as p index. we need to figure out some logic to this p index, which is in fact a global variable. So let's declare that. So again, this is equal to 3, it returns back, and iterates again. F equal to 1, we'll be having 0 to 3 1, and it returns back, and the for loop fails. Level will be again decremented and returns. So level will be 2 now, and F is 2 as well. So swap will be doing its function, will be having 0312, and function is called again. Level will be 3, iterated 2 times. Swap 032312 and returns, and again F is 1. This will be created, and now again level 2 returns, and again F fails. Level 1, it returns to the level 1, and now F will be 1. Okay, fine. Now we need to figure out a way that somehow swap will receive the parameters accordingly, that it can assign proper values to the PA according to the P index, and P index will be having the variables coming from the swap parameters. So we need to figure out a way. Let me take a break. I'll come in 10 minutes. Hello. 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 So let me write down this function clearly somewhere. So this is the function. It receives level, right? So level will be incremented, and we have a for loop. Let's name it as f. So f will be condition minus level, and condition let's declare this as a global variable, and condition is equal to n plus 1. So within this, I have swap function that takes level minus 1 and f value. And after that, if the level is equal to n minus 1, then we have to return back, or else we will be calling the function again, return function with level. So after this, we will decrease the level. So far so good. We need to implement this swap function. So main agenda of swap is to assign values to the PPA, and the index will be changing accordingly. It depends on actually level will be same for all the values, right? So at level 3 only, I mean at the very basic level only, we are assigning the values, so it doesn't matter what the level is. And we can consider f as a parameter because sometimes it is 0, sometimes it is 1. So f can be either 0 or 1. Maybe this is also not a good way of considering a parameter. Maybe we should keep track of every assignment, I guess. Maybe I'm really sorry. We will declare a global variable that it tracks the index. Okay, I have already created that. So this is the variable. So we'll do one thing. After each and every successful assignment at the very base level, we usually return the function, right? So we will do one thing. So whenever we are returning from this. So this condition, we will increment the index value. Okay, so we'll do one thing. Let me make sure that my logic is correct. So whenever it comes here, it checks the level and it returns back. Initially the index will be 0, so whenever it is returning, it should get incremented to the next pointer. So the next iteration, the loop will go again. Yeah, I'm correct as I think. Let me open the braces. We will change the index before we return, and the index will be incremented according to the size of the n value, right? So initially p index will be 0. P index is initially 0. So initially it is 0, and after successful assignment we'll increase that by n. N is the size 4, so it will be pointing to fourth index of the PPA. So maybe this must work fine. We'll close this, so it returns back, and again swap will be called, and within the swap, of course, we are using p index, right? So now it will point to PPA of 4. So now it will assign from here, and again it returns back. PPA will get incremented to 8, right? Wait. PPA index will be, yeah, it will be incremented to 8. Okay. We need some other variable as well. It should have a iterative, iterative variable which will take care of the other elements, k0, 1, 2, 3. So this must be included. Okay, so that has been taken care of, but we need to define a logic that actually help us to swap the numbers, right? So at the very base level, 0, 1 is fixed. So the level is, since we passed the level, we're at level 3, and it will be passing 2. So we have 2, right? So basically from index 2 we will separate the array and take out the second and third element of the array, and then Mm, So far we are done with the indexing. So we just need a way to sort out the array. So at the very base level, we have this 0, 1, 2, 3, and over here we need to swap these two, and the swap will be given L minus 1, that is true, which is okay. So we are done with this, and then we will be heading towards 0, 2, 1, 3. Level 2 F1, level 2 F1, level 2 F0, level 2 F1. should I do now? So the very base level I have 0. This has to be this value has to come from level 2, right? Level 2. So this value again will be coming from level 1. So it is kind of passing the values from 1 to 2 and 2 to 3, and we have to retain this, and again at the second iteration we have to swap these. When we go back to this iteration, which is again swapping this number, we'll get 0, 2 and 3. Level 2, so level 2 में तो first one will be fixed and the other part will be changed. Okay, and the second one will be, so I think I have got the logic, I guess. If I say, let's say, let me just write down my logic that I have got strike in my mind, or else I will forget that. Let's say in this level I have, if I focus over here, so here I have, it is level 3, and at the swap 1 I will be having 0, 1, 2, 3, and during the swap 2 I will be having 0, 1, 3, 2. So it is kind of, you know, we are giving level 3, right? So level 3 swap will be having a parameter 2 and f as well, and here as well. So this 2 is kind of fixing first 2 elements, and the duplicate will be created from second index. So I will be having elements from index 2 to n minus 1, right? So n minus 1 is 3, so 2, 3. So I'll have 2 elements. So during the first iteration I will be just, I'll just pop the first element out, I'll push the remaining elements to the right, and since there are no elements, this will be held over here as well as it is, and this popped out element will be placed back into its as usual position. It's placed in the front position, so you'll be getting the 0, 1, 2, 3, and at the second iteration when f is 1, um, Hello, hello. So f is 1. So this duplicate array, in this duplicate array, this element is popped out and the remaining elements will be shifted to the right, and again this popped out element is pushed to the front. So I'll be getting 3 2. And again, if I go back to the level 2 and the iteration is switched to F1, and during F1, so since it is level 2, we use another color, level 2 swap. First swap will be given 1, level -1, which is 1, and the iteration as well. Iteration is, let's consider as F, which is 1. And now this actually is done. This is return, and it goes to F1. We swap this, and the function is called again, and we will be heading towards the two loops. This is what we have. So here we need this element, basically 0 1 2 3. We'll fix this one and we'll change this according to the f value, and the f is 1, right? So in the array 1 2 3, this is 0, this is 1, this is 2. We'll pop the first element, first indexed element. We'll pop this, we'll shift this to the right, and we will again push this element to the front. So we will be having 2 1 3, so which is what we desire of. And during the swap 2, in the level 2, right? Okay, in level 2, in swap 1 it is as usual, I mean as it is, and f equal to 2. इसमें तो 0 1 2 3, right? Okay, 0 1 2 3. Here we fix this one because this is 1, and 1 2 3 is taken out, and f is 2, so we pop this second element out and we push this to the right, and 3 is placed to the front, so we'll be having 3 1 2. So this is how we get this 0 3 1 2. Within this level 3 swap, this is 2, and that means the first two elements are fixed. The f value is 0. F value is 0 and it is 0, 2 and 3. That means 1 is popped out, so as it is, and f is 1, 3 is popped out, we'll get 3, 1. So yeah, so basically whenever we are in this iteration, in this level, we need the previous level value, and if we are sorry, if we are at this level we need 0, 2 and 3. If we are at this level we need 0, 3, 1, 2. So this is only possible if we keep track of some kind of variable that indicates the um, level. Like other than this level 3, 2 and 1, we need vertical levels as well. So this is some kind of level A, this is level B, this is level C, like that. Or else we can do something more meaningful. Let's say this is level R naught. Wait a second, this is C naught, column 0. This is level C1 and this is level C2. That in the sense level column is equal to 0, level column equal to 1, level column equal to 2, and these will be level row 0 or else 1, whatever, level row 1, level row 3, 1, 2, 3, like that. So with this we can sort of handle these values. Whenever it goes to the other level, it's level 1 and column 4. This will be column 1, column 2, column 3, column 4, column 5, column 6, column 7, column 8, column 9, column 10, column 11, column 12. So each column will have 2 elements. So total 12 columns giving us 24 elements. So each column will be holding these values. And those hierarchical values will be having this, and the parent, the very base will be element number of elements, that is n. So I think we have almost got the logic. So so far we have got the logic that can, if I have a array, I know where to, mm, kind of, from where I should split this array out with the help of the level. So with the help of level, I can split the array. I can store that in duplicate, and within that duplicate, I can swap the values according to the f value, right? So that is taken care of. Um, but I need this array first. So this array depends on the column that we are presently working at. I mean, presently we are at which column, that decides the array. So if if we are at the column 1, then our array will be 0 1 2 3. If we are at column 2, then the element array will be 0 2 1 3 0 3 1 2, and so on, like that. And even for this as well, this is column 1, this is column 2, this is column 3. So column 1 it is 0 1 2, column 2 1 0 2, column 3 2 0 1, like that. So for level 2, there will be a parent array as well, which is standing at the level 1, that is 0 1 2 3. And for these three columns, 1 0 2 3 is the parent, and for these three, 2 0 1 3 is the base, and for these three, 0 1 2 3 is the base, very base, I mean. For these three, 3 0 1 2 is the base. So for all these four elements, base element will be 0 1 2 3. So how do we track this out? So we have PPA of 0 holding this value, 24 holding this value, 48, 72, and so on. So we have to write a logic that actually access this particular indices. So maybe now it is clear that we have to we have to create a column variable, global variable. Let's create that first. So this is column, and it is in fact an array, right? Is it an array? No, it is not. It is not an array. Basically it holds the value, right? So let me just declare it as int. So initially it is at let's say 1. Initially it is pointing to column 1. Sorry. So since we need a reference array, take that. What the hell? Give me a minute. So column value has to be updated after, I mean, if we go over here, as we uh, as we move from the base level to the upper level, when we are decreasing the level, we should increment the column value. So C plus plus, so column gets increased. So if it is initially at 1, it will get to incremented to 2, and then to 3, and then to 4, so on and so forth, up till maybe, if the combinations are 24, then it will go up to this much of value. So yeah, so with the help of this column value, I need to change the reference array. So the reference array will be, so initially it is 1, right? Maybe we should make it as 0 for the sake of indexing, we'll make it 0. This is C naught, this is 1, this is 2, this is 3, C4, C5, C6, C7, C8, C9, 10, 11. So this will be going up till less than combinations by 2. So initially it is at 0. So I have to change this initial value to 0. So the reference array will be uh, reference array will be reference array will be PPA of, we have to use column, and with that we need something else as well. So here we have 0, 1, 2, 3. Here we will be having 0, 2, 1, 3, right? So this is basically PPA of 8, right? So this is PPA of 8, and this is PPA of 16. So 0 to 7. Here we have 8 to 15. Here we have 16 to 23. And from here it is 24, and 24 to 31, 32 to 40, so on. So basically column is 1 right now, so we have to increment it by n into 2. N into 2 is 8, so 8 into column is 8 as well, because column is 1 right now. So we'll be having pp of 8, and when column number is 2, it will point to 16. So I think we got the logic. So C is multiplied with n multiplied by 2. So n is multiplied by 2 because at the very base level we have 8 elements, right? So after covering all these 8 elements, the column changes. So with that, yeah, we are good to go. So this is the reference array. So reference array keeps change. Wait. We have already created okay, the PPA only, right. So PPA will be into n into 2. Actually we don't use n, instead of that we use size, right? Okay, we'll use size. 5 into C. So we have this. So we have the problem solved. Let me check it again. So this will be having, okay. So the reference for this level of swap will be for this level of swap will be C is 2, so 16. So PP of 16 will be, oh, there is a problem, right? We don't know PP of 16. What is PP of 16? If I go over here, let me rub this out. So firstly, in the first iteration, we have 0, 1, 2, 3 because swap is called level 0. From 0 onwards, we have to take the array. So initially reference, we need to have a reference variable, right? Okay, PPA will be swap. In the swap, I have 0 and the iteration is 0. So the first element will be popped out and pushed to the front, so remains as it is. But from there we get this. Let's say we somehow got this. Again, when it goes to the function, we will be having 3 iterations. So starting from f0, again swap is called, and again it is level 2, right? So level 2 minus 1. So 0 is fixed and f is 0, 1 is popped out. Again 0, 1, 2, 3 is kept as it is, and again function is called level 3 2 times. So first 2 elements kept fixed, first element is popped out, again it is remained as it is, but now it satisfies the condition level equal to n minus 1. So it goes to f1, and now it pops out 2, and it pops out 3. So yeah, the logic, what's the logic in this? How do we get the 0, 1, 2, 3 over here? So the column is currently pointing to 0. Okay, currently column is 0, this is 1, this is 2. So it has to point to, it has to point to the previous level first element, right? and I can just column 0, this is PPA 0 is holding 0 1 2 3, which is actually good. And I can now PPA 4 will be holding this 4 to 7, and when it goes back, column will be incremented to 1, and now F is 1. Again, swap is called. The swap is called. It has the reference of mm, it has the reference of column 1, which is PPA 8. It should be having level 2, which is 1. So wait a second. So 0 is fixed, right? So from 1 onwards, we are taking out F1. So we need the very base reference. 0 is fixed, 1 is popped out, these are pushed back, and 2 is placed in front. So again, reference will remain unchanged, right? Reference will be unchanged. But the storing element is only changing. That I have included somewhere over here. P index plus K. So reference is unchanged. And when it goes here, zero to 1 3, and column is 1, F is 0, level 3, So initially we will assign PPA with these values, like entire, I mean, combinations into n. All these elements will be filled up with these values, and whenever the swap function is called, it will take the reference of the PPA at the very first. If we take the very first case, in level 1 we'll be having f equal to 0, so swap is called and the parameters will be level -1, right? So it is 0 and the f is 0 as well. And the reference is simple, right? Column multiplied by as you can see over here, column multiplied by size into 2. This is 8, this is fixed, column is 0, so PPA is pointing to 0th index. So in 0th index we have 0. The following 3 elements are also accessed. Total 4 elements will be accessed. So those 4 element array is referred, will be acting as a reference array. So with that reference array, we'll be calling the function again. We'll go to level 2, and in level 2 it will be iterating for 3 times, and again the swap is called and it is once again referencing to PPA of 0. So again 0, 1, 2, 3 will be the reference array, and again the function is called. We get into level 3, and now we have again column 0, reference variable, reference array will be 0, 1, 2, 3. So now from now the condition fails here, I mean level is equal to n-1, so it goes to f equal to 1, and here PPA of we have to assign the value, right? I think I have wrote some logic over here. P index will be increased, right? So as you can see over here, P index is increasing. So PPA of P index equal to some array of elements. That array of elements will be written from the logic, that is reference variable, reference array is taken, which is 0, 1, 2, 3, and it is level 3. Then 2 elements are fixed, last 2 elements are taken out. Sorry. So since it is f equal to 1, first element is popped out and pushed to the front. So thus we get the 0, 1, 3, 2 at PP of 4. Okay, fine. And again P index is increased to 8, right? 8. Now level is decreased, we go back to level 2, and column is increased, column is now 1, and now the reference variable is once again C into 8, right? That is 8 PPA of 8. PPA of 8 is 0, 1, 2, 3. So 0, 1, 2, 3 swap function is called. We're at level 2, so first element will be fixed and the other three will be uh, dumped into duplicate array, that is 1 2 3. So in 1 2 3, since f is 1, we pop out first element, first index element, which is 2. So put 2 is push it to the front, we will get 2 and 3. So that is pp of 8, right? pp of 8 to 11. And again the function is called, swap is called again, and the reference will be pp of 8 as well. So here when the swap is called, this is level 3, so level 3 minus 1, that is 2. Two elements are fixed, last two are mutable, it can be swapped, and f is 0. So first element, that is 0th index, will be popped out, so it remains as it is. And we go back, and here f is 1, so 3 is popped out and push it to the front, so we'll get 0 2 3 1. It goes back to the level 2 and column is increased to 2. And now reference is ppa of 12, which is 0 1 2 3 again, and it is level 2, right? So first element is fixed and last three are moved to duplicate array, f is 2. So second index value is popped out, we get 0 3 1 2, and the function is called again and the process goes on. And again when we go back to level 1, column will be this phase, right? So column will be 4, I mean 3, index 3, column 3. And now pp of 8 8 3 is 24, right? So 24, which is right over here. So here we have 0 1 2 3. So this 0 1 2 3 again level 1, right? So 0th index, so entire elements will be moved to duplicate array. In that duplicate array, f is 1, right? First element, which is 1, is popped out and pushed to the front, so we get 1 0 2 3. We go back again. God, we finally got the logic. The only thing is we need to implement swap function. Swap function will take level -1 value and f value, and it returns nothing, so void. इसमें तो in this we need a duplicate array which is 0 every time, right? I mean size will be n, right? So instead of creating a new memory every time, we'll just use a global variable for this. So I guess I have not declared anything. Yeah, duplicate तो यहीं पे है. So I'll create a duplicate pointer, and this will be instantiated, I mean A memory will be allocated during the start of the program. We'll write it over here. Duplicate will be equal to int star clock n comma, or else we can use size now. Size comma size of int. So we are good with the duplicate. So the duplicate array will be holding the values of PPA. This depends on the level. So if the level is for loop goes from, and duplicate size also varies, right? I forgot to mention that it is not always for duplicate to change. No, it does change as well. Maybe we have to create it over here only. We'll do one thing. So int star duplicate equal to int star lock, and and I have created some logic over here. I remember I have created length and all. Maybe it's in the VS Code, right? I have done that in VS Code. Where is this length size of array? Yeah, this one. So this duplicate size depends on this parameter. So what do we maybe we'll just declare this as level only. So level, and this is f. So level will be having the duplicate size, right? Let's name this as d size. So if it is at level 3, then we will be passing 3 minus 1, which is 2. That means we are focusing on second index element, leaving 0 1 as it is fixed, So this one and n minus 1, right? So size minus 1, which is 3. Maybe we can simply say size minus d size. So size is 4, d size is, for this condition, is 2, and since we need only 2, so this satisfies. And for level 2, 2 minus 1, which is 1, size minus d size is 3, and that works well. So this is correct. So size minus d size, comma, size of int, so this duplicate duplicate array will be holding the mutable elements of the reference array. So we need to assign those values now. So we need a for loop. 0, a must be less than this much, right? So size minus d size, this will be 2 now, for now. So a plus plus. So within this, duplicate of a equal to reference variable will be ppa, right? So ppa, now ppa is, for now, it depends on column, right? I think I have written this. Yeah, this one. PPA of C into size into 2. So this is the reference. Let's say column 0, PPA of 0. Since we actually don't assign this, instead it depends on f, right? So if f is 0, then we will, no, it doesn't depend on f, it actually depends on this one, d size minus d size, d size actually, to be precise. Depends on d size. D size, wait a second, this value plus d size. See, if the column is at 0, this will be 0. I mean, this entire thing, and it will be added to the d size. D size is depends on the level. If it is at level 3, then it is 2, right? So we are accessing pp of 2, and we need another parameter as well, which is a. So this is how we will assign duplicate elements to the dupe array. So after assigning this, we need to shuffle, right? We need to shuffle according to the f value. So we need some logic that can shuffle things out. Shuffle karna hai, and it depends on f. So f indicates which element has to be popped out, right? So we need some logic over here, block of code, and at last, after all this struggle, we can this is a index is incremented. Okay, after all this, we will assign ppa of p index with the dupe array. So this requires a for loop. So with this, we will be having the entire logic of permutations. Let's test this out after lunch break. Let me have my lunch. See you in 20 to 30 minutes, I guess.
If I could, I would get myself out this mess. If I could, I would get myself out this madness. If I could, I would get myself out this mess. If I could, I would get myself out this madness. If I could, I would. And if I could, I would. If I could, I
A good developer can understand technical concepts and also codes well. But only a skilled developer can create a robust and extendable system. If you wish to become a skilled developer, you must attend this low-level design free masterclass by Scalar on solid principles. In this session, you will gain a thorough understanding of the solid principles and use them to create robust, maintainable, and extendable systems. Click on the link below to join and don't forget to attend.
When you're launching a new product with a tight deadline,
2 weeks?
Grammarly's tone suggestions can help motivate your team with a positive approach. Because you know we got work to do. Looking good, team. When it's time to pitch your product to clients, a more personable and friendly approach can help sell it. And look, they bought it all. With Grammarly, getting the tone just right makes a big impact on your team's success. Click the blue button to download Grammarly today.
Just
I suggest.
Headphones, bro.
You know I suggest. Say it's time. You know I suggest. You know I suggest.
Oh man, you need some headphones, bro.
You know I suggest. You know I suggest. You know I suggest. You know I suggest.
Oh man, you need some headphones, bro.
You know I suggest. You know I suggest.
The answer might surprise you, but do you know how much time it took for me to create this amazing Excel report? 1 minute. Yes, all I did was use ChatGPT and AI inside Microsoft Excel, and it gave me this stunning report. And the good news is you can integrate ChatGPT and AI tools inside Microsoft Excel to write 174 Excel formulas without having to remember any of it. You can now create all your Excel.
They took my money.
Let's get money, motherfucker. Get money. Get money, motherfucker. Get money. Let's get money, motherfucker. Get money. Get money, motherfucker. Get money. We gon' burn it down. Burn it down. We gon' burn it down. Burn it down. I killed it, it's murder. I killed it, it's murder. I killed it, it's murder. I killed it, it's murder.
I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker.
Show them. Change the station with a new shit. Show them. Change the station with a new shit. Change the station. Change the station. Change the station with a new shit. With a new shit. Change the station. Change the station. Change the station with a new shit. With a new shit.
It's murder. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker.
I killed it. I killed it. I killed it.
I killed it, it's murder.
Show them. Change the station with a new shit. Show them. Change the station with a new shit. Change the station. Change the station. Change the station with a new shit. With a new shit. Change the station. Change the station. Change the station with a new shit. With a new shit.
I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder.
Go crazy, berserker.
I ain't feeling lonely, and I wanna admit it's time to end the ride. Fading it too slowly, were those gonna lift me up this time? You were the only one who got me tripping up inside. All the words you told me, am I reading something different from your eyes? See you for a moment, even though that I can feel you. See you, all that I wanted was to tell you that I need you. See you for a moment, even though that I can feel you. See you, all that I wanted was to tell you that I need you. Now I'm finally right here with you.
Do you want to learn Python from
We're gonna burn it down. Burn it down. We're gonna burn it down. Burn it down. I killed it, it's murder. I killed it, it's murder. I killed it, it's murder. I killed it, it's murder.
I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker.
Show them. Change the station with a new shit. Show them. Change the station with a new shit. Change the station. Change the station. Change the station with a new shit. With a new shit. Change the station. Change the station. Change the station with a new shit. With a new shit.
It's murder. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker.
I killed it. I killed it. I killed it.
I killed it, it's murder.
Show them. Change the station with a new shit. Show them. Change the station with a new shit. Change the station. Change the station. Change the station with a new shit. With a new shit. Change the station. Change the station. Change the station with a new shit. With a new shit.
I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder, go crazy, berserker. I killed it, it's murder.
Go crazy, berserker.
No. So we need to shuffle, right? Sorry. So for this logic, we have the duplicate array. Let me name this as level. So the size will be equal to size minus level. So here I will use the size and replace that wherever it has been used before. And this is level, right? PPA 0 level. If it is at level 3, then this will be 2, this will be 2, so yeah, level. So let's say I have 0, 1, 2, 3, and it is at level 3. So our variable level will be 2. So these two will be fixed. and these two will be changed according to the f value. So loop will be having the 2 3 values. So I need to pop the f index value. So in general, if I take an array, this is the first element, 0th index, first index, second index, and so on. Let's say n minus 1. For simplicity, I have 5 elements with me. So if the f value is 1, then I need to pop this out and I should push all these elements to the right. So 0 will so 0 will come over here, and 2 3 4 remains as it is, and the popped out value will push it to the front. So this is the logic that I have to design. So we know the sorry, so we know the entire size of the tube, right, which is d size. So maybe we will store the popped out value in pop. So whatever the value that has been popped out, so pop equals to do of, that will be decided by f. So we have stored that value, and we have to go in a reverse order, right? So if at all f is 3, let's say f is 3, then I must have popped this out, and this will eventually migrate to this, and this will be assigned to this second value, and this popped out value will be flashing at the front. So we need to create a for loop that starts from, let's name it as z. It starts from f and it goes it should be greater than 0, and it keeps on decreasing. So let's say f is 3, z value will be 3, and loop of c. will be assigned with dupe of z minus 1. So dupe of 3 is assigned with dupe of 2. So this goes on, right? So z becomes 2 and dupe of 2 will be having dupe of 1 and dupe of 1 will be having dupe of 0. And when z becomes 0, this fails, and at last we need to assign dupe of 0 with pop value. So that's it. So this is popped out and it went in to the starting, right? So this is the logic. In this way we can shuffle the array. So later on we will be assigning this duplicate array to the PPA. So this depends on initially it is 0 1 2 3, right? So it's kept constant, it remains unchanged, so there is no problem at all. So p index will be pointing to 0, right, initially. So 0 will be assigned with initially f is 0. So 0 1 2 3, 0 will be popped out and z equal to 0, it should be greater than 0. So nothing works out. Dupe of 0 is just 2, right? Yeah, 2. So this remains as it is, and the assignment should start from index plus not 2. It changes according to the level as well. Because it is at level 3, it is level 3, it is PPA of 2, but when it comes to level 2, it becomes PPA of 1, and in level 1, it becomes PPA of 0. So it is nothing but level minus 1, right? So I have already assigned this. Okay, wait a second. This is actually level minus 1, right? As you can see over here, this is level minus 1. So I can simply use level. I can simply use level for this. So p index plus level इसके बाद है ना, we'll just move this down. this as well. So for int int final right g equal to 0. Let's keep this as it is now, undefined. PPA of p index plus level is equal to dupe of g. So this keeps on iterating until it ends, until it goes to the end of 2, and dupe will be of d size, right? So d size, so g plus plus. So we will be having the updated shuffled values in the PPA, and we are good to go. So it has been shuffled. This is the entire logic. So we need to write the code. So the function receives the n value. So with this n value, we are gonna be printing out the possible permutations. Like if n is 4, the numbers will be 0, 1, 2, 3, right? So with these numbers, the possible permutations will be printed down, and all these are using priority array, right? So we'll continue with that later. First, we will check this out. I need 0, 1, 2, 3, 0, 1, 3, 2, 0, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1, and so on. So let's see. So first of all, I need n. So let me take the input from the standard string. So ampersand of n. From here I need to create a function that actually calculates number of permutations possible. So that is already been created. So this is the factorial, and what is this? This is combination of n. Whatever, this is the permutations possible. So combo will be holding the let's name it as permute. The number of permutations will be stored in this permute. So initially product is 1. So later on we need to declare a global array which is PPA, and size of PPA depends on permutations, and the permute, right? Permute multiplied by the n, and this is size of int. So PPA has been allocated some block of memory, and we have to implement this logic. ये तो यही है. So this is a function. Okay, it returns something. Okay, int, let's name it as func, and it takes input level and f, and within this we need to increase the level. Okay, level is global variable, right? So int level, initially it is 0. So level plus plus. Actually this should be, wait a second, function is level, level is global Can you use global variable identifier image in this function parameter? I'll just out. For now it is accepting it. Actually you don't need this. तो swap में चाहिए था. So level plus plus need to have a for loop. F is less than n plus plus. Okay, condition is n plus 1, right? So condition equal to this is not possible. We will assign it over here. Condition is equal to n plus 1. So this will be condition minus level. So initially it is at 1. LV is undefined. What? So in this I have swap function. Okay, I made a swap function which is void type. It doesn't return anything. It accepts. Let me declare it as LV and F. I'll call swap level minus 1 F. I think I am in a right way. Okay. After calling that, we'll check for a condition whether level is equal to n minus 1. If it is equal, we need to, n is not there. Okay. Then condition minus 1. Okay. Minus 1. Okay. If that is true, p index will be incremented. Okay. P index initially it is 0. Now it is incremented by n, just condition minus 1. And it returns back, return 0. Else, if the condition fails, we'll just call the function again, recursive function, right? And okay, return frequency of level so after that for loop failure I need column which is initially 0. This will be incremented and level will be decremented, return 0. This is the logic and we need to implement swap. First thing we will do is t size and adding end equal to size and size equal to n. So size minus that level will be given to t size and with that I'm gonna be creating duplicate array this will be d size comma size of now we are assigning PPA has initial values, right? So I forgot that this has I need to create a loop and y equal to 0, y is less than we'll come to that again, y plus plus PPA of y is equal to so within this where is the combination permute? Okay, we will run this for permute number of times. For n equal to 4 it will be 24. So I took 24 times and within this I need another for loop that will iterate for n times, giving out me values from 0 to n minus 1, sorry. So PPA of y into z into z into z, no, not into z, y into m plus z. So initially y is 0, n is 4, this is 0, so 0 1 2 3 will be assigned with z, and again y is 1, so 4 is assigned with 0 1 2 3 and so on up till 23, right? 23 into 4, 80, 92, 92, 93, 94, 95. Okay, so PPA is equal to 1, sorry, 0 1 2 3 comma copy paste 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 paste. So it will be assigned like this. If you want, you can check it out. We'll check it over here. Array. So PPA is over here. Permute. So we have com, right? There is com. Copy paste. So we have com as well in permute. Com. Okay, I have not saved this. PPA initialization. So yeah, paste this. Printf %d and after that I'll create a new line and space anything. Let's give 3 0 1 2 0 1 2 0 1 2. So there are 6, right? If I give 4, there will be around 24, right? These are 6, these are 6, and these 6, and these 6. Okay, done. So it's working. We need a for loop. Int a equal to 0, a less than d size, less than d size. Okay, a plus plus. In this, we have column, we have size, we have level, and whatnot. So do of a equal to PPA of column multiplied by size, which is n, and 2, right? Okay, into 2. This will be added to level and a. So here level is input parameter, right? So this is LB. So after that, we need to shuffle it down by making this code. Shuffle. So pop will be popping the element. So in pop equal to dup of f. We need a for loop for in c equal to f, c greater than 0, c minus minus. Okay, dup of c equal to dup of c minus 1, and at last dup of 0 is assigned to pop, and at the very end we will update the PPA, right? So for loop in g0, g less than d size, and g plus plus. PP of index level, p index, p index, p index. Okay, PPA of p index plus level, right? This is LV. This is equal to 2 of G maybe we can check this out. Implicit declaration of function swap. Swap. Okay. In function func, implicit declaration warning, and okay. Yes, implicit declarations. Okay. So I have 0 1 2 0 1 2 0 1 2 0 1. Okay. 2 2 0 1 2 0 1 2 0 2. Okay. After function is called, okay, this is completely written out, right? Cut this. Okay, we will look into this. Let's see. Wait, wait. Column is 0, size is 3, 6, and then 0, and this is 0, this is 0, PPA of 0, which is 0, and 1, 2, of 0, okay, is 0 times and 0. P index is initially 0. So why did I get triple two? Group of A what the hell? I'm really sorry for that audio. Did I miss something? Why did I use return over here? Why here? Maybe commenting this down with work. Fine. So this part is working fine. We need to check the shuffled part. This is working fine, and this is shuffling, right? So we need to check the after shuffling. With new indexes, and use the input. Okay, this is not increasing, man. Index is 0 initially, and the level is uh, level is 0. So after every iteration, it should wait. LV plus G. Copy this, paste it over here. Printf after shuffling. So then swap returns, and here level is currently 2, so and this is also 2. So the index is increased. I think this return 0, so it returns back here. Wait a second. Let us assume that n is 3. Okay. Let us assume that n is 3. So the array will be 0, 1, 2. So 0, 1, 2 will be the base. 0, 1, 2, 1, 0, 2, 2, 0, 1. And in this, 0, 1, 2 is one possibility. 1, 0, 2, 1, 2, 0, 2, 0, 1, 2, 1, 0. So this is so I have called this function with the value 0. Instead, I can even call like this because level is a global variable. So when I go to function, level will be equal to L. Okay, it is increased to 1. So let me note down all the values. Level is 1. Level is 1. F is 0. Condition is 4. 4 minus 1 is 3. So we have a loop. We have a loop. That goes okay. So we have called swap. Level is currently 1, so 0 comma 0. So if the parameters are 0, then t size will be, for this t size will be size is 3, so this will be 3. And duplicate will be assigned with 3 blocks of memory, each will be in bytes of size. And column is 0, size is 3, so this will be 0. LV is 0 currently, so dupe of 0 is assigned with 0, 1, 2, right? As you can see over here, 0, 1, 2, okay. And after shuffling, okay, this is 3. Date value is assigned to index is 0, always 0. So PPA, okay, 0, 1, 2. Return function is called, which is right over here. Okay, function is called again with the value 1. So level will be incremented to 2. Now again there is a for loop. For loop f0, f less than, condition is 4, this is 2, f plus plus, swap will be 1, 0. So if I go to swap, this is 1, size is 3, so 2, d size is 2, and 2 blocks of memory is allocated. It repeats for 2 times. This is entirely for this one, right? I'm sure this is for this one. So 0, 1 column is actually 0 for now.